Okay, today's challenge is to figure out why our American Dryer Corporation, I think it's an 8285 or something similar, they have a bewildering number of models, is not making heat. This is an all-electric model, obviously very commercial, obviously very big. I've downloaded manuals. They are ambivalent and kind of quirky, so I'm just going to dive in and see what I can figure out. I believe there are reset buttons for over temperature and or manual or automatic reset. So I hear tell there may be one in the lint system here, in the lint screen area up underneath. So I'm going to remove it and take a look. And the first hang-up seems to be this appears to be a little tab that keeps the lint basket from being extracted, and it looks to be rusted kind of solid. So I'm going to go hit it with some lube and see if I can get it loosened up so I can pull the lint basket all the way out. Okay, got my trusty PB blaster. Let that soak in for a couple minutes, wipe up the excess so it doesn't end up on lint. And we'll see if we can get it open. Okay, a little helpful hint. The basket doesn't want to come out because this will catch on the inside lip of the housing. You just need to push the lint basket back inside, reach up underneath, and fold this down to release it. Don't know why it's designed that way, but there you go. Okay, and I'm thinking that can't be too good. There's clearly way too much lint on the electronics, and I'm assuming that the thermal switches are in that mess somewhere. So I'm just going to have to get in there and clean it up after I disconnect power. It's too early in the week to get electrocuted. Okay, I'm going to use my non-contact voltmeter just to sniff around, see if there's anything still hot here. There isn't. All right, so let's get rid of this giant pile of lint and see what we can see. Oh my gosh. Okay, I'm going to use the phone to get up above this and see if I can get a clue what I'm looking at above here. There's 4 devices wired kind of semi in series, and those are the thermostats, and I think the one on the right is the reset button, so I can't really tell a whole lot about it until I clean up some more lint. Okay, using the best manual I can find online, which may or may not be a gas model, that's very ambiguous. This panel has 4 items in it. The first one closest to the end where it's connected is going to be the manual reset thermostat, and after that is a series of higher and higher temperature thermostats, apparently switches that I'm presuming close at the particular temperature. So what I'm going to do is I'm going to just start testing end to end and look to see what I've got. To see, this one is the one that has my interest and I think might have something to say to us. And basically you can see that all 4 are connected to a common line on one side, and the other 4 lines come out through this connector here, shown as number 1. So I'm going to pull off the wire, the individual wire here from this end reset thermostat, and check it and see if it's open. If it is, I think I found my problem. Okay, finally in position to check the manual reset thermostat, and you can see it is closed. So I'm just going to go down the line, disconnect one line and check them the same way. Check all these thermostats and see what we got. Another potential failure point is this switch. If the dryer senses that the lint door is open via this switch, it will shut the dryer down. So I'm going to be checking to make sure that this plug I'm getting a closed indication here. Make sure the switch works. All right, I've got the plugs. I've got the probes into the socket, which is convenient. And right now it's showing me an open circuit, which is what you'd expect. I'm going to push the little button closed, and I am getting a closure. So that tells me the switch is good. So I'm going to plug it back in. Okay, here's my next clue. Inside the back, I've taken the back top cover off. There is at least a connection to the heater. You can see it's a three-phase unit. You can see the schematic for the relay that's on the bottom. Those three switches are part of the relay that is controlled by that green and purple wire coming down through the high limit switch. Now all I gotta do is find all that, and that will tell me whether or not I've got a good connection through my high limit switch, which could be open, causing the relay not to kick in, or there could possibly be a bad relay itself, or even bad heater elements, I suppose. So just have to figure out where all this stuff is now. All right, still operating off let me get some perspective here. This is the top portion. This panel comes off. There are two screws on the front and one hidden one over here that I had to do by feel. That's on this side because I've got this gigantic dryer tube here. But basically, this is the contactor that's in that little schematic I just showed you. Colors are a little different. You can see clearly the green wire coming to it, but it has got a red wire to the other side of the contactor coil. So if you follow it up, you see that what is presumably the high limit switch that's up there on top with the two red wires coming into it. I hope you can see that. Kind of hard to get the camera really where I need it to be, so let me just zoom in on it a little bit. That's that device that's kind of in the center of the screen now. So I'm going to get my meter probes in there and see if I got a closed circuit across that switch, because if it's open, the contactor will not kick on. So let's check it out. Okay, so a few very fiddly minutes later, I have managed to get my probes into the sockets that connect to that high limit switch, and I'm getting 0 ohms across them. So that means that the switch itself is presumably closed, which means that any current coming in through those wires should be pulling the contactor closed. Okay, I suppose that's maybe the next step, is to figure out if we've actually got power coming into those two terminals, which run forward somewhere. You can see the green wire and I guess the red wire, yes, go into their own little umbilical cord, which runs to the front. You can see this, it's a small cord that runs up on the top. It's the highest metal conduit that runs up front, which I'm guessing I have to take the control panel off, or the front panel off the machine to get to. So we just keep digging. And one of the easier steps, 2 screws right on the front, and the whole panel hinges upward. We see where that conduit terminates, which is behind that little box in this interesting looking device, which I will cover later. Okay, I got this off. The micro switch is actually connected to this cover, so you have to clear it from this sail. This is the sail switch. I wondered where that was, reading through the manual. There it is. It reacts to air pressure inside the heater core, the heater box, you can see. So when air is blowing, it will throw this switch to make sure it stays in the right position. I did test it, and the switch itself is actually good. I'm reading 4.6 ohms across it. I suppose that's the circuitry that's associated with it, so that's probably correct, but it does go to 0 ohms when it's closed. So that would be with the switch. I will make sure that it's in the right position when it's running, but basically you can see the green wire comes in through here and goes right back down this conduit into this control board, which opens with a single screw up here, and is this green wire here going to this plug, and just a matter of chasing it around and it goes to chassis here. So very interesting. And possibly the most significant discovery is that there is a tiny little package up here that has information, and it's got a schematic. Let's take a look at that. Okay, interesting. This 21-year-old document here. I'm chasing down how to turn on the heater units. This is the contactor we were looking at. If you look, the red and the green wires here that we've been chasing, this limit switch that we verified is good, comes into this plug, comes all the way around. One side is grounded, and you can see that the red wire goes in through this series of all those little switches down in the lint trap area that we saw. And you go up here and you see it's also connected to the door switch, and there's also something called a lint switch. Now, folks, I don't know what a lint switch is, but I gotta believe if there's a problem with lint, this machine has it. So I'm gonna go looking for this connector and chase it up and try to figure out what this is, because I believe if that's open, it also is gonna keep the whole thing from working. So let me dive back into the lint box and see if I can get even nastier. Okay, those 4 yellow wires appear to be part of that circuit that I'm looking at. We've already checked out this door switch, which we know works, but these other 2 wires, I believe, are the lint switch. Now, if you follow it up, you see through the shadows and all the bad stuff, that's the lint switch up there. And I don't know exactly how that works, but I gotta believe if its job is to sense excess lint, it's probably screaming bloody murder by now. So I'm gonna clean that off and see what's underneath it. Okay, so this is the lint switch connector coming directly down from the lint switch. Okay, I'm connecting through the back. I'm getting 0 ohms, and I'm going to wiggle it around just to see if it changes. Anything going on up there. So apparently my lint switch is okay. So next I'm just going to plug it back in where it is and go on to the next step. And by the way, that's what I pulled off of that whole assembly up top. So there was a lot of lint. All right, having struck out there, I think what I'm going to do is I'm going to repower the machine, and I'm just going to check and see what kind of power I have here. Clearly I'm going from the chassis to that power, and I believe the contactor is probably 24 volt control, because I did find this did float out of this area when I opened it. At any rate, I'll just measure and see if I've got any voltage going back there and work it from there. Basically, the schematic will give us the ability to trace this thing back. But basically, the contactor goes through the high limit switch, which we've tested, the sail switch, which we've tested, into this connector, and we will at least get it to that point and see if we have any power there. Okay, going from ground to the red wire, I've got 27.3 volts AC, which sounds exactly right. So the question is, what in between that power supply, that's basically up here. So that means I'm sending power down this line. That means the only thing in between is the sail switch and the high limit switch to the contactor. So now the question is, this is running, is the sail switch working? Aha, you can hear the contactor kicking in. You see what's happening here, folks? Apparently this sail switch is supposed to be pulled in when the air is flowing. Let me I'm just gonna manually push that in and see what happens and see if we get some heat. I believe, yep, there they go. The heater's on. So the problem is the sail switch is just not quite working for whatever reason. Okay, here's the thing. There's almost no airflow going into the heater box. I can hold a piece of tissue next to the air inlets at the top, and it barely moves. Now the thing is, there's the fan driving the process. Now, watch what happens when I turn this off. Watch the direction of the fan blades. Looks like it's going the right way, but then you see after the stroboscopic effect stops, it's actually pulling air this way. Okay, maybe you old school dryer techs are laughing at me right now, and well, I deserve it, because I honestly didn't notice the drum was rolling counterclockwise. That goes hand in hand with the fact that the blower motor is running backwards, which means this is a three-phase unit. So what's happened is that two of the phases have been reversed. And it strikes me what's happened lately is this building was rewired to accommodate a large new generator, backup generator, and whenever they hooked it up, I'm sure they just swapped a couple of the phases coming into this building. And so this particular machine is running backwards. So what we have to do now is get the guys who wired it up to come in and swap those phases. Not only to fix this, because I could just go in the electrical box behind on the wall and swap them there and be good to go, but I don't know what else in this building might use three-phase and run into the similar kind of issues. So we'll get that done, and I will report back on the video to let you know how it goes. All right, it's tomorrow already, and the electrical contractors who put in the emergency generator came out and swapped those two phases around. Now, that's all it took. We are good to go. We are making heat, we're moving air, and you can see we're back to clockwise rotation for the drum. So we're done.